Hello and good evening, CSI257 students, for the first 8-week term of the fall 2014 semester at Anne Arundel Community College. This evening's PacketTracer tutorial is a fantastic activity on summarization, and we're going to be taking a look at PacketTracer activity 8.3.1.2, and this is going to be the Skills Integration Challenge. Alright, so as you can see over here, we've got quite a bit going on in our window here. We've got an IPv4 network here, and we have an IPv6 network over here, and as you can see, chances are we're going to end up doing some summarization. Alright, so the scenario is, in this activity, we're tasked with implementing EIGRP for IPv4 and IPv6 on two separate networks. Our task includes enabling EIGRP, assigning router IDs, changing hello timers, and configuring EIGRP summary routes, and we're going to make sure that we limit EIGRP advertisements. Alright, so let's go ahead and jump in with the activity, and we've got here requirements. So for EIGRP for IPv4, it's asking us to implement EIGRP, and it wants us to do it initially. We're going to go ahead and start here. Let's see what we've got. So implement EIGRP v4 on all routers using Autonomous System 1. So let's go ahead, and first things first, let's get all of the routers up here, and we're going to bring this over here. So there's router 1, IPv4 edge, and this should look very similar. This is very similar to the summarization activity that we did earlier in one of the other Chapter 8 activities. Alright, so we've got router 1, router 2, and the IPv4 edge router. So implement EIGRP on IPv4 enabled routers using Autonomous System 1. So let's start with router 1 here, and we're going to go ahead and log in. We are in user exec mode. We'll go to privilege exec and then to global config, and I'm going to type in router EIGRP 1. And so that's going to enable the EIGRP process on router 1. We'll pull up 1941 here, the IPv4 edge router, go from user exec into privilege exec, and then into global config, router EIGRP 1. And we'll do the same thing here on router 2, from user exec to privilege exec, into global config, router EIGRP 1. Alright, so on the IPv4 side of the house, we've been able to enable EIGRP with the autonomous system number of 1. So the next step says use the classful network address for the loopback interfaces. Now, it's interesting, in reading this here, it's kind of confusing what they're asking for, but what they're really stating is for the network statements that we would enable under EIGRP, it wants us to use classful network addresses for those loopbacks. So if I were to say network 172.31.0.0 and the and that'll be it, right? So that would be our network statement. So 172.31.0.0, and then that's going to cover, because again, by default, that is the classful network address for a Class B network is going to be a /16 by default. So if I were to pull this out and say no network 172.31.0.0, then we no longer have that entry in there. So we want to enable EIGRP on all of the IPv4 interfaces that fall under this classful listing. So if I were to do 255.0.0 and do a do show run, and let's come down to the EIGRP section, you can see here that we've got our network, and it doesn't actually take that 255.255, it just simply says network 172.31.0.0. Alright, So we've made that classful entry there for the loopback interfaces, and we may need to come back to that, but let's take a look here and see what else happens. So it says use the wildcard mask to advertise the /30 networks between R1, R2, and IPv4 edge. Alright, so the /30 networks will be these networks here, the serial connections, and if we scroll up a little bit, you can see the serial interfaces. And so between the IPv4 edge and router 1, we're going to be 172.31.6.2 and 6.1 respectively. And then between R2 and IPv4 edge, we're going to be 10.10.8.1 and .2 between the edge router and the router 2. So we're on router 2. Let's take care of router 1 first here. So we're on router 1. Oh, and I apologize. I think I entered those on router 2. I did. So we need to go ahead and negate this. I thought I was on router 1 there. All right, so I'm on router 1, so I would say network 172.31.0, excuse me, .0.0, and that is actually the right place for it. Same statement, need to make sure I get it on the right router. All right, so we've got that entered in there. Now let's go ahead and configure the /30 networks between R1, R2, and IPv4 edge. And let me go ahead and do network. And so R1's network is going to be 172.31.6.0, and then we're going to use the wildcard mask 0.0.0.3. And so what if I use the wildcard mask here? If I said 0.0.255.255. We'll do show run. Remember previously when we entered in the 255.255, it didn't take because we were using the classful representation of the address. And again, even with the wildcard mask, it does not take it. And that's for this network statement here. So even if I do the 255.255 or use the wildcard mask of 00.255.255, still it's going to put this classful entry in there for us. Okay. So we've got the first network statement added in there, and the network is .0, and so then it's going to be a /30, and we are on router 1, so that should be correct. All right, and then let's go ahead and take a look at the IPv4 edge. So no loopbacks on the IPv4 edge that we need to take care of, so we're going to go ahead and configure the first interface network, and that's going to be serial 000, so it's going to be 172.31.6.0, and it's 0.0.0.3 for a 255. And as you can see there, we now have our neighbor adjacency is up. So if I do a do show IP EIGRP topology, you can see that all of our routes are in a passive state, and that's what we want. If I take a look at the neighbors, so there's our first neighbor, and that is router 1. And so you can see that the 0 is indicating that that's the first host, or the first router that we've established an adjacency with. You can see the address of the router that we've established the adjacency with. And this is the interface on which that adjacency has been established. So we've got that adjacency up. Let's go ahead and do the same configuration, and this is going to be on network 10.10.8.0, and again this is a /30, so 0.0.0.3, and we've got that network statement added in there now. So if I do a do show run, let's see what we've got here, and so there we go. So again, no loopback interfaces to add in here. So we've got the network statement for the 172.31.6 and the 10.10.8.0. All right, so we've got some work to do down here on router 2. As you can see, we want to use a classful entry down here. So I'm going to go ahead and say network 10.0.0.0 and hit enter. And that's enough to bring up that adjacency. And so for those loopback addresses that we had, this network statement is going to encompass everything in the 10.0.0.0. So it also encompasses the serial link between R2 and the edge, but we need to make that a /30. So we're going to say network 10.10.8.0 and make it a /30, and so we're going to add that in. And so now if I do a do show run, and I'm wondering, let's see, do show run and then section EIGRP, yeah, so that doesn't work, so we'll just do a show or a do show run. Was trying to shorten up where we start. So there you have it. So we've got a more specific 10.10.8.0 network there, but we also have the classful network, and that is for the loopback interfaces. Okay, so we've used the classful network address for the loopback interfaces. We've used the wildcard mask to advertise a /30. So let's see, do show IP EIGRP neighbors. And I have a neighbor relationship, and that is going to be with the IPv4 edge. So what if I say do show IP route, and we can take a look at the routes that we're learning about. And right here, we're learning about the 172.31, and so that's the entry for the loopback addresses, the /16, that we had advertised from router R1. All right. Okay, so we've got R1, R2, and IPv4 edge. It says use the default method to only allow EIGRP updates out the active EIGRP serial interfaces. So within router config, if I do the passive interface default, and I'm on R2, the next thing I'm going to want to say is no passive interface, and that's going to be no passive interface serial 00, and router 2 is serial 001. As you can see there, we just went down, but then as soon as I remove that serial interface from the default passive method, it brings it back. And let's do that same thing on router 1. And remember, the passive interface default command puts every interface into the passive interface mode so that none of the interfaces at this point are sending EIGRP hellos and exchanging information. So then we're going to go ahead and say no passive interface. Whoops, no passive interface serial. And off of router 1, this is 000. All right, and so then that neighbor adjacency comes back up. And let's jump onto IPv4 edge, and we're going to say passive interface default, and the IPv4 edge has two interfaces, so I'll say no passive interface serial 000, and then we'll say no passive interface serial 001. And so that's going to go ahead and maintain those interfaces as part of the EIGRP autonomous system. So if let's take a look at our routing table. So do show IP route, and what do we see? So we're learning quite a few addresses here. You can see we're learning the 10.10.0, 10.10.1, 2, 4. So we're learning about all of the loopback interfaces. We're also learning about, and that's from router 2, the 172.31s. Right, we're learning about the loopback interfaces off of router 1 as well. Now you'll notice that we have no gateway of last resort for the IPv4 edge. So if I were to try to ping either of these servers right now, let's take a look at the IPv4 server actually. And so that IP address is going to be 64.100.10.1. So from router 1, what if I try to do a do ping 64.100.1.10? As you can see, we're not having much luck right now. And it might have something to do with the fact that we're missing the default gateway. All right, so we've used the default method to allow EIGRP, or to only allow EIGRP updates out the active EIGRP serial interfaces. So advertisements should not be summarized. And so right now we are not. So the next step is to configure a directly attached route on the IPv4 edge, default route that is, and propagate that into the EIGRP updates. And so that's where, when we do the do show, whoops, I apologize there, I jumped down. So when I do the do show IP route, you'll notice that the gateway of last resort is not set on R1. Do show IP route, it's not set on R2, and as we just saw, it's not even set on the IPv4 edge, and that's definitely one that we want to set. So we're going to go ahead and we're going to type in exit, and I'm going to type in IP route, and we're going to make a default route here, whoops, with quad zeros. And we're going to go ahead and send that out serial 010. Let's make sure that it wanted it to go out. Yes, these are the default, configured directly attached and propagated in the EIGRP updates. So we're going to go ahead and use that as the default route. We're saying out the serial 010 interface, which is this interface right here. And now I'm going to go back into router EIGRP1, and I'm going to say redistribute, and we could do static, RIP, OSPF, EIGRP connected. We're going to say redistribute static because we've just created a static route. So if I do a do show IP route now, you can see that our gateway of last resort is set to the network 000, which is out serial interface 010. So how do R1 do show IP route? As you can see here, it's going to be our next hop, right? Is our default route. It's going to come out here to the IPv4 edge from router 1. This interface right here is the 172.31.6.1, and router 2 now should also be seeing a default route, and he is, right, out the interface right here. All right, and we also can see the default route listed here. And basically what this is D stands for EIGRP. The asterisk means it's a candidate default. EX means it's an external EIGRP route, and therefore our administrative distance is going to be 170. This default route is via, so this is where we would go to exit to get to that default route. It's the 1010.8.1 interface, and it's out serial 001. All right, so we've added in our default route. It's propagating into EIGRP, so configure the serial interfaces between R1, R2, and IPv4 edge to send hellos every 10 seconds. So let's start with R1. We'll do this in order here. So we know that R1, it's in serial 000, and we're going to go ahead and say IP hello interval and EIGRP1, and if I do a question mark, you can see here number of seconds between the hello interval. It's asking us to set it to 10, and so we're going to go ahead and set that to 10, and we're going to come to 1941, so we're going to go into interface serial 000, whoops, and we're going to do the same thing. IP hello interval and EIGRP1 10. And we're going to go into interface serial 001, and we'll run that same command, IP hello interval EIGRP10. And again, this is just simply tweaking the hello interval just a little bit. So if I do a do show IP protocols, let's see if we see any interesting information here. So we'll scroll back up to the top. So the routing protocol shows us the autonomous system number is EIGRP1. We've got no filters. We've got some K values that are listed here. Redistributing, right? So this actually shows that we are redistributing static routes into EIGRP1. Automatic network summarization is in effect. And so it says automatic address summarization is 10.0.0.0/8 for serial 00, where we did not use a wildcard mask, we use the classful boundary. And we're routing for 2 networks, and it lists out our passive interfaces here, and then it shows us our routing sources. So show IP protocols is a good command to refer to kind of get a high-level overview, a snapshot of what's taking place within your routing domain. Okay, so we've changed IPv4 edge, so let's go back over here. We'll go to int serial 001, and it's going to be IP, let's keep spelling hello wrong, hello interval EIGRP1, and we're going to set that hello interval to 10. All right, so we've got that set, And next it says, on R1 and R2, configure an EIGRP summary route for the loopback networks. Okay, so now we're going to configure a summary advertisement, because on 1941 right now, if I do show IP route, as you can see here, we've got the 4 loopback addresses in here for router 2, and then we've got the 4 loopback addresses for router 1. And we want to go ahead and consolidate this. So the addresses are listed here, and we'll come back over here to the notepad. And again, you can definitely count on summary being a skill that you need to make sure that you understand and that you have down. And so hopefully this is going to help. So we've got 4 loopback networks. So we'll say 172 dot, what are we looking at? 31.0.0/25. We've got 172.31.0.128/25, and we've got 172.31.1.0/25. So basically just carving up /2, 2/25s is equal to 1/24. So it's 172.31.0.0/24, and we've carved that into 2 smaller networks here. So we'll go 172.31.1.128/25. So again, these 2/25s equal 1/24. But we want to do a summary here. So again, as we've previously done, you can see that the first 16 bits in each of these addresses, the 172.31, those are identical, right? So we've got 16 bits here that match already. However, the 3rd octet is now our interesting octet. In fact, let me flip over here to a little red. So the 3rd octet, this is the interesting octet right now, because as you can see, this is where values no longer match up. So if we break that out into, we go from decimal to binary, so we know 0 is going to be 0, 0, 0, 0, 0, 0, 0, 0. And so then the zeros are easy, 0, 0, 0, 0, 0, 0, 0, 0. And then the 1, same thing. 4 zeros, 3 zeros, 1, and then again, 2, 3, 4, 1, 2, 3, 1. So we've got lots of bits here. In fact, 7 of those bits are going to match. It's this last set here that don't. And so in addition to the 16 bits that already match, we have 1, 2, 3, 4, 5, 6, 7 more. So we've got a /23. And we know those /23 is 255.255.254.0. And again, we've got all zeros here, so none of these values are in play. So our summary is going to be 172.31.0.0/23. And so the 0.0/23 actually represents 2/24s, and they are, write it all out here, 172.31.2.0. So it's going, this /23 is basically saying that it's going to include, oh, I apologize, .1. So /23 will represent 172.31.0.0 and 172.31.1.0. And so that /23 equals 2/24s. And these would be the 2/24s, and you'll notice that these 2/25s, it's basically 172.31.1.0/24 and 172.31.0.0/24, right? If these were not /25s, but they represent a single /24. We basically took a single /24 here and we carved it up, and so we're saying that in order to encompass and to account for those 4 subnets, this will be our summary route, /23. All right, so let's go ahead and let me take a look back here real quick. So configure on R1 and R2. Okay, so on R1, that is our summary. So we are going to go into interface serial 000, whoops, and this is where, if we do a question mark, we're going to set the IP summary address, EIGRP, autonomous system 1, and now our address. So it's going to be 172.31.0.0, whoops, and our subnet mask is 255.255.254.0. And we're going to leave the administrative distance as the default. So again, before I hit enter, as you can see here, if I do the do show IP route, we see a lot of 172.31s, right? Oops, we're learning from EIGRP. However, when I broadcast, when I go ahead and hit enter here and change this and make it so that it's a summary address that's being advertised out, as you can see, we've got that soft restart there. It's seen over here as well. So now when I do the do show IP route, you can see that we do not see a ton of addresses. Whoops, excuse me. We see a single summary address, the 172.31.00/23 that we're learning from EIGRP, and we see this single summary that represents the 4 summary routes that are listed here. All right, so now we need to do the same thing for router 2. So let's go ahead and get into interface serial 001, whoops, 001, and IP summary address EIGRP1, our autonomous system number. And let's take a look at these IPs. And again, it's going to be very similar. Where are we at here? It's going to be very similar to what we were just doing. So again, we're looking at 10.10.0.0/24, and then we also have 10.10.1.0/24 and 10.10.2.0/23, and then 10.10.4.0/22. So again, we're not too concerned about these CIDR notations right now. We're going to go ahead and take a look at the bits. So again, 1010, it's the same in all of the addresses, so 16 bits right out of the gate are going to be the same. So here, and let me go ahead and change colors dramatically here. All right, so here is the interesting octet, and we need to summarize all of those. So 0 is the easiest one, right? We're going to be 000, 000, and then we've got 1, 0000, and then we've got 2, 0000010, and then we have 4, 0000100. And so if we take a look at this now, we'll switch over to the green here. We match all the way up to right there. 1, 2, 3, 1, 2, 3. I'm going to have to shift a little bit. So there we go. So we've got 5 more bits that match. So 1, 2, 3, 4, 5. So when I add the 5 with my 16, I get a /21. And so a /21 is going to be 255.255. And then the next 5 locations are going to be added in. So it would be 128 plus 64 is, whoops, plus 64 is 192, 224, 240, and then finally 248. So 248.0, and that is going to be the net mask and the CIDR notation for our summary route. And so it'll be 10.10. And again, you can see here there's no bit position where the value is on. So it's 10.10.0.0/21. And so let's see if this works. So we'll step over here, and it's going to be 10.10.0.0, 255.248.0, and let's see if that is an accurate summary representation. So that was on router 2. I'm going to jump onto the edge. We've had the soft restart there. So I'll say do show IP route, And sure enough, there is our summary route. 10.10.00/21, and it represents all 4 of the networks that are shown over here. Now, what's interesting, and this is again something to keep in mind as you transition into the 150, or I should say the CSI 158 course, but when you're working with ACLs, right? And it also comes in with summary routes. So we've got 3 bits here that didn't match. So the number of actual networks that we're representing with this summary right here is 8. However, there are only 4 networks here. We do have a /22 and a /23. So if we were looking at them in terms of /24s, this guy would equal 2 /24s, and the /22 would equal 2 /23s, or 4 networks. So we've got 6, 7, 8. So keep in mind that we are representing 8 different networks here, and we don't have all of the combinations here to see what they would be, but if we did, they would turn out to be .0 all the way up to .7. So those 8 networks would be represented. So to be 10.10.x.0/24, if we were talking about /24. So 0.24, .1.0.24, .2.03, so forth and so on, up to 10.10.7.0/24. Again, just another way to check to see like what exactly are the networks that are being represented with this summary. All right. So we've got that summary address in there. Let's move on here because we've got some other activities to do. So R1 and R2 should have only 4 EIGRP routes in the routing table. And that includes the default route. So if I do a do show IP route, let's see. So 1, 2, 3. So I only see 3. So I've got the 10.0.0 and I've got the 172.31. So it's 2, 3. So I do not have 4. So something could be wrong here. Let's check on router 2. Do show IP route, and router 2 sees 1, 2, 3. So again, each of these is missing. It looks like each is missing a route. And so let's take a look here. Is the default route should only have 2 EIGRP routes in the routing table. So let's take a look at the edge. So if I do a do show IP route, I should only have 2, but I have more than 2. All right, so we're going to have to go back and take a look at some things here to see what did we not do correctly. And it could be that it deals with the classful advertisement that we had earlier. All right, so let's do a check results. Let's see where we stand right now on our assessment items. So look at this. On the edge, it doesn't look like auto summary is enabled. And then this is going to be our IPv6 tasks. And it does have something to do with that auto summary that we were talking about earlier. So let's jump in and let's take a look at that. So if I go on to router 1 and I do a do show run, and we look at the EIGRP, it says auto summary. So it is auto summarizing our addresses, and we do not want that. So we'll say router EIGRP1, no auto summary, right? And if we come back here toward the top where it actually talked about advertisements should not be summarized. So we want to make sure that we do the no auto summary. So IPv4 edge, same thing, router EIGRP1, no auto summary. Again, we've got a quick soft restart there, and then we've got router EIGRP1, no auto summary. All right. So now when I take a look at router 1's routing table, do show IP route, we should have 4. So I've got 1, 2, 3, and then the default route for 4. We're good there. So we'll do a do show IP route on router 2. So there's 1. So router 2 still only sees 3. So there may be something up here with router 2. So let's do a do show run. And I want to see the EIGRP. And we've got our no summary, no passive interface is correct, passive interface default. All right, what does router or the IPv4 edge see? Do show IP route. And it should see 2, so there's 1 and there is 2. So it looks like on router 2 we could be missing something. So let me go ahead and do a do show run here real quick. So let's see the IPsef. We've got our loopback interfaces. We're not using gig 0. We are using serial 001. We've changed our hello interval. We've got the summary address 10.10.0.0 as a 255.255.248. Passive interface default looks good there. So do show IP route. And I still only see 1, 2. Am I not seeing the D's? Yeah, I only see 3 still. So I see the summary recreated. Oh, whoops, I'm sorry. That's to the null interface. So I see the 172.31.00/23, which is a summary we created there. I also see the default advertisement that we're picking up from the IPv4 edge router. And we are missing one more advertisement. All right, so we're going to come back to this in just a second. I'm going to push on into the IPv6. So we're going to pick up right here with IPv6. So on the IPv6 side of the house, we want to implement EIGRP on IPv6 enabled routers using AS1. So let's go ahead and we'll start with router 3, and we'll bring these guys down here. So we'll start router 3. We'll take a look at the IPv6 edge. And router 4. So we've got a lot going on in this activity. Alright, so starting back on router 3, and we'll walk through each of the routers. So we'll go from user exec to privilege exec into global config. And the first thing that we need to do is implement EIGRP using Autonomous System 1. So remember, chances are if I tried to do any IPv6 configuration that dealt with routing, the first thing you want to do is remember that IPv6 unicast routing by default is disabled on the router. So we'll take care of that first, and then we'll type in IPv6 router EIGRP. We'll use Autonomous System 1, and I'll hit enter. And so not only is the IPv6 unicast routing not enabled, remember when you enable the autonomous system with the IPv6 router EIGRP command, if I do a do show run, we should see, and we do, that it's actually shut down by default. So not only is unicast routing for IPv6 not enabled by default, but once we go in and enter the router configuration mode for EIGRP, that is also shut down. So we're going to say no shut because we want to make sure we bring that process up and have it active. So the router 3 router ID, it wants us to set it to 3.3.3.3. Oh, I apologize. We're going to need IPv6. I'm drawing a blank here real quick. There's an EIGRP router ID. There we go. EIGRP router ID is going to be 3.3.3.3. So we'll set the router ID. So we've done a couple tasks here on router 3. Now let's step over to the IPv6 edge and go from user exec to privilege exec into global config. And the first thing we want to do is IPv6. We want to enable that unicast routing for IPv6. All right, so we've got that knocked out, and so then we're going to type in IPv6 router EIGRP1, and again we want to do the no shut to make sure we bring that process up right away. And then IPv6 EIGRP, I'm sorry, it's just EIGRP router ID. And I'm so used to, once you get into the IPv6 configuration of everything having IPv6 in front of it. But we're in router subconfiguration mode here. So EIGRP router ID for router, or the IPv6 edge, is going to be 1.1.1.1. And let's see what's next here. So we're going to jump on router 4 and user executive privilege exec into global config and IPv6 unicast routing. We want to make sure we enable that routing. Then IPv6 router EIGRP1 and no shut, because we want to bring up the routing process and have it start. And then let's see here. Then we want EIGRP, I got it right there, router ID 4.4.4.4, and so we'll get that router ID set. So now it says configure a directly attached default route on IPv6 Edge and propagate it into EIGRP updates. So we're on the IPv6 Edge router here, so I'm going to exit out and I'm going to say IPv6 route. And remember, it's not the quad zeros because that's an IPv4 construct. So we want to go ahead and do ::/0, and that actually represents the default route in IPv6. And so we're going to set that up so that it's using, and let me double check the interface here. On the IPv6 Edge, it should be this guy right here, serial 010. So we're going to say serial 010. And so I've just added in the default route. And then, of course, the next thing we want to do is we want to propagate that. So IPv6 router EIGRP1. And if I do a question mark, this is where we would find our redistribute static. And that's it. So we're not doing any metrics. So we're just redistributing the static. So we want to make sure that that static route gets pushed down to R3 and R4, and what you commonly refer to these as, when these routers here, R3 and R4, same thing with R1 and R2, they only have one way out of this network, right? And it's out this interface. So typically, these would be called stubs, and you would configure these guys as stubs, and all you would give them is the default route, basically telling them, hey, this is how you get out of the network, because they've got no other way out and they've got nowhere else to go. So typically they refer to these as stubs. So let's pull up R3 here. If I do a do show IPv6 route, let's see if we're picking up the default route. Did it get propagated down? I don't see it. And there's a reason for that. Think about it. So we've got the process configured, we've got the default route is in there, right? We've set it up. However, EIGRP for IPv6 doesn't seem to be functioning. And the key thing to remember here is with EIGRP for IPv6, we actually have to enable it on the interfaces. It's not enough to simply enable the IPv6 for EIGRP router configuration globally. We need to jump into the interfaces. And so let's go ahead and I'll type in interface serial 000 and IPv6, and there it is right there, EIGRP, and then our autonomous system number, right? And so that's going to enable that IPv6 process on router 3. Let me jump onto IPv6 Edge, so we'll say int serial 000 and IPv6 EIGRP1, and then int serial 001 IPv6 EIGRP1. And as you can see, we just established a neighbor relationship, and it's looking at the link local address to establish that relationship, and it's out 001. So let me jump on on router 4, and we'll go into interface serial 001, and let me double check to make sure. Yeah, router 4 is 001 and router 3 is 000, and those should match 001. They do. Okay, so we're going to say IPv6 EIGRP1, and the neighbor relationship has been established. So if I were to do a do show IPv6 EIGRP neighbors, I can now see that from router 4's perspective, I see a single neighbor out the serial 001 interface, and here is the link local address. And it's key point that it's going to establish that adjacency, it's going to use that link local address. So IPv6 edge, let's see what IPv6 edge sees. So do show IPv6 EIGRP neighbors, and we should see 2, and we do. We see router 4 out the serial 001, and we see router 3 out the serial 000 interface. All right, so we've got those guys added in, and let's scroll back down here. Okay, we've got the router IDs directly attached default route. So let's see, now do we see this default route? Do show IPv6 route. Are we picking up that default that's being redistributed? And we are. And there it is right there. And again, the S is a static. Shows that and I apologize, I'm on the edge, so I need to jump over here. Thought I was on 3 or 4. So do show IPv6 route. And there we go. I was looking for an external, I didn't see it. So here it is right here. We've got the external EIGRP route to the default network, and it says via FE80, and it gives the IPv6 address out the serial 000 interface, and this is router 3. So he would go out this interface over to the IPv6 edge. So is R4 picking up this default route? So we'll say do show IPv6 route, and he is. And you can see it right here. All right, so we are redistributing that static route. So on R3 and R4, we're going to configure EIGRP summary routes for the loopback networks. And so again, this is going to be a little more work than we had initially completed when we did the IPv4, because we're dealing with IPv6, and IPv6 is in hex. So let's see here, Control Z. All right, so we've got R3. We'll do R3 first. So let's take a look here. So we've got 2001 colon DB8 colon, and then we've got 1 colon 1, whoops, 1 colon 1 colon A000 colon colon 1/72. And so then again, I won't write all of these out. We're going to go ahead and stop it right there. We're going to start right there, I should say. So, because this is the interesting hextet, right? The interesting hextet is where they no longer match, and this is it. So A000, A100, A200, and A300. So they match here, but then this nibble, and we'll talk about the nibble in a second. So this is the interesting hextet, and then within that interesting hextet, we've got an interesting nibble here, because it's interesting because they no longer match. So let's take a first look here. Remember, the hextet in an IPv6 address is 16 bits per hextet. So we've got 16 here, 16 here. Even though there's a single character here, there's still 16 bits there, and there's still 16 bits right in there, right? The 1 and the 1, if we were to expand that, would be 0001. And so that is 16 bits, because remember, these are hexadecimal characters. They are not binary characters, and they certainly are not decimal characters. And then the A is also 4 bits, and I'll actually do the 4 down here. So it's 4 bits, right? Because it's a nibble. And remember, a byte is 8 bits, a nibble is 4 bits. So we're basically subnetting on the nibble boundary here, right? The second nibble that's in here. All right, so how many bits match right out of the gate? And it's the same process that we used with IPv4. We've got 16 times 4, which is going to be 64, and then 4 is going to be 68. So right out of the gate, we've got 68 bits that match. Now we need to convert the hex into decimal, and that'll make it easier for us to convert it into binary. So luckily for us, right, and on the R4 loopback addresses, we'd have to deal with the A and the B. But here it's very easy. These are the decimal values, right? For hex 0 is equal to 0, hex 1 is 1 in decimal, hex 2 is 2 in decimal, hex 3 is 3 in decimal. So let's take a look at what that looks like in binary. And remember, these are only 4 bits. So in binary, 0 is going to be 0, 0, 0, 0. 1 would be 0, 0, 0, 1. 2 is going to be 0, 0, 1, 0. And 3 is 0, 0, 1, 1. All right, so from looking at this, let's switch over here to red. From looking at this, you can see that the bit boundary within this nibble, right? So this is the nibble, which is equal to 4 bits. 4 bits, right? The bit boundary here, we pick up 2 more bits that match, but then that breaks down. So 68, we know right now that we've got our prefix length. And remember, it's not subnet mask, it is prefix length, L-E-N-G-T-H, is going to be a /70. And the value here is 0. None of these bit positions are active because it's all zeros. And then everything after it becomes a 0. And the same principle applies. We've got 2 bits that don't match, so 2 to the 2 equals 4. So we're going to be representing a total of 4 networks here. And they are going to be the 4 networks that you see right up here. Okay, so it's a /70, and it's the prefix length. And so we're looking at 2001 colon DB8 colon 1 colon 1 colon, and now the A, remember the A was still there, it's going to be A000 colon colon /70, and this is our IPv6 summary route that's going to represent all 4 of these networks. And so let's try it out. Let's see if this actually functions. And I'm on router 4. Definitely want to be on router 3. So from router 3, I'm going to go into interface serial 000. I'm going to say IPv6 summary address. This is the same as IPv4, except we say IPv6 summary address for EIGRP Autonomous System 1. If I do the question mark, you'll notice it wants the IPv6 address. So we'll say 2001 colon DB8 colon 1 colon whoops colon 1 colon A000 colon colon /70. And let's see if it takes it. It certainly does take it. We've got a soft reconfiguration, but is that correct? So let's step back over here and take a quick look, because I'm not confident that that's correct. So we've got the /70, and what did we do? Did we do anything wrong? Nope, it's still zeros. So it'd be A000, and I'm not certain that that is actually correct. So let me pull that out of there. And I want to see, does a soft reconfiguration. So we're going to go ahead and leave that in there for right now, but I'll come back to that. I want to double check that and see if that's actually correct. I'm not confident that that's correct. We could have a mistake. All right, so let's go ahead. Well, actually, you can check that right now, in fact. Take a look at the assessment items. You can see here we're all green, EIGRP v4, right, looking good. And we come down to EIGRP v6, so on router 4 the summary address is enabled. So take a look at this. So again, we have to enable EIGRP v6 on all of our interfaces, and that even includes the loopback interfaces, which I had totally overlooked. The same loopback interfaces that we're dealing with right now. So let me pull router 3 up, and I'm going to do a do show run, see how they have them numbered, loopback 0, 1, 2, and 3. So let's say interface loopback 0, and it's going to be IPv6 EIGRP 1, and then int loopback 1 IPv6 EIGRP 1, and then int loopback 2 IPv6 EIGRP 1, and int loopback 3 IPv6 EIGRP 1. So you should definitely be very skilled at making at enabling IPv6 on an interface, loopback, or physical. Okay, so it's been enabled there, and I'm going to go ahead now. We're going to hop over here to router 4. And now we want to do a summary address on router 4's interface up to the edge, and that's going to be the serial 001 interface. So here's the networks that we're looking to summarize. So int serial 001, IPv6, summary address EIGRP1. We know it's going to be 2001 DB8 colon 1 colon 1 colon. And let's go over here and take a look and see what it's going to break out and what it'll be. I'm going to flip the page here, but we may be going back to that page shortly. All right, so we've got 2001 colon DB8 colon, make sure I'm getting this right, 1 colon 1 colon, and so now we enter the interesting hextet. So BB80, and then we've got BB90, and then we have BB alpha 0, and then BBB0, right? And these are, they all end up with colon colon 1/76. And so we want to summarize these. So you can see again we've got 16 bits, 16 bits, 16 bits. So these 4 hextets are the same for all the addresses, and in fact the first 2 nibbles in that hextet, or the first byte of the hextet, is also the same. So we've got 8 additional bits that are going to match right out of the gate. So we've got 64, and then 8. So we're looking at 72 bits right now that match. However, the interesting octet is right there. Let me switch colors here. So our interesting octet is right here where they do not match. And so 8 in decimal is 0. I apologize. Let's back up here. Control Z. So 8 is going to be 1000, and 9 is going to be 1001. A in decimal is 10. B is 11. So 10 is 8010, and 11 is 1011. So this equals 11, this equals 10, this equals 9, and this equals 8. And so again, looking inside of the, I'll change it to black here, looking inside the nibble where we're subnetting within the nibble boundary here, we're looking around, we see that these match, but that's where it stops. So we pick up 2 more bits. So we know our prefix length is going to be a /74. So I'll say prefix length is going to be a /74. And here's what's interesting. This value in this bit boundary here is enabled. So that value spot right there within these binary numbers is 8. It's equal to 8, right? So our summary address is going to be 2001 colon DB8. Whoops. Uh-oh. I apologize. I've had this happen before. Escape. I'm going to get out there. I think it... There we go. Okay. Whew. Save my page. So DB8 colon 1 colon 1 colon. And so the BBs are the same. And it's going to be 80 colon colon /74. And so that IPv6 summary advertisement will represent all 4 of these networks. And so let's put that in and let's see what happens. So 2001 colon DB8 colon 1. Oh, I apologize. Yeah, no, that's actually correct. Yeah, so the 8 is correct. Okay, I was thinking I needed to go back from decimal, or from binary to decimal to hex, but the value of the 8 is the correct value. So colon 1 BB8 0 colon colon /74. 74. And so we've added that in. We've got soft reconvergence that takes place. So if I come up here to IPv6, we should see, if I do a show IPv6 route, we should see the summary routes. And here's our /70 that we're receiving. And I don't see the /74. And why is that? We're going to figure that out. So I see the interface, or I see the summary advertisement for the router 3 loopback addresses. The router 4 loopback addresses I do not see. And so maybe that's wrong. Let's take a look. Let's check our results and see what it says. So we'll come back in, check the results. Aha! Again, once again, the loopback addresses, you'll notice it's interesting. If IPv6 is not enabled on these loopback addresses, then it doesn't advertise that summary for us, right? So let's go ahead and hop in here and let's do a do show run and get the numbering, and it's going to be loopback 8, 9, 10, and 11. So interface loopback 8, IPv6, EIGRP1, interface loopback 9, IPv6, EIGRP1, interface loopback 10, IPv6, interface 1, loopback 11, IPv6, EIGRP1. And so now we've enabled EIGRP on those 4 loopbacks. So now let's go take a look at the 1941 or the IPv6 edge with the show IPv6 route. And as you would expect, there are the 2 summaries that we're looking for. And so again, key point to remember, when you're summarizing loopback addresses within PacketTracer, and I don't have anything set up right now to test this out for you real quickly with GNS3 or with my equipment even. So, but when you're dealing with those loopback addresses, make sure that you are enabling IPv6 when you're using them in summary advertisements, or else it won't advertise them. And that's actually something that I'm going to check. I'd like to follow up on and check to see if that's actually the case with the real Cisco iOS. All right, so let's scroll down here. We've got 4 routes in each routing table. We only have 2 routes on the IPv6 edge. And so that's correct. And verify R3 and R4 can ping the IPv6 server. The IPv6 server should also be able to ping the loopback addresses. So let's do that. So let's jump on the IPv6 server, and we're going to get the command prompt up. And we're going to type in ping 2001:DB8:1:1:A000:1. All right, so we can ping A000. Can we ping, is it A100::1? We can get to that loopback address. So we're going to be able to get to all of these loopback addresses, and that works as well. So we've confirmed connectivity. However, there's still one thing outstanding here. You'll notice that our score shows 90 out of 90. If I check results, we've got green checks everywhere, right? So it shows that everything's done. However, let's go back to the IPv4 situation over here, where on router 2 we should see 4 EIGRP addresses. So here's 1, 2, 3, and 4, so we're good there. Let's check router 1. Show IP route. Do we see 4 here? We do. 1, 2, 3, and 4. And so that is also resolved. So show IP route, and here we should see 2. And we do. We see the /21 summary, and we see our /23 summary. All right, so I really enjoy these skills integration challenge activities. Absolutely fantastic to pull together a lot of the information and the skills that you've been learning about, and gives you a great opportunity to demonstrate your mastery of those skills. So this concludes the PacketTracer video tutorial for the 8.3.1.2 Skills Integration Challenge, where we were working with EIGRP for IPv4 and IPv6. We were doing route summarizations. We were setting router IDs. We were redistributing static routes. And in our case, our static route was the default. We were using the passive interface command. So again, a fantastic activity. We actually went through the calculation of the summary routes for IPv6. We did two different sets of networks, and we also did that for IPv4 with two different sets of networks on the IPv4 side of the house. So again, a very great activity here to really pull together your skills. So this concludes this PacketTracer tutorial. I hope this has helped you out and increased your understanding of summarization, EIGRP, and IPv6. All right, have a fantastic evening, and I'll see you this Saturday.